Hello, welcome back to part 2. We're going to pick right back up. This is 6.3 cumulative probability. So we have the probability of x is less than 2 on x distributed binomial probability of 4 with probability of 0.75 like we've been doing. So we want to know what is the probability of 2 or less, right? So that's why it's all the way to the left, it's 2 or less. Remember this little guy here is going towards the 2, so he wants to eat the 2, so this one has to be less than 2. I know it's a really childish way to say it, but it works. So it's less than 2 all the way down, so we want to know the cumulative probability of 2, 1, and 0. So recall the cumulative probability concept. The cumulative probability is the probability of that value or less. The probability of x less than x corresponds to the left of the tail. Cumulative probability function. So the cumulative probability function lists cumulative probabilities for all possible outcomes. Remember the example of cumulative probability function for our x distributed as binomial probability of 4, probability of 0.75. So here it is. Our probability of x is less than 0. Less than or equal to 0. Remember we calculated that at 0.0039. And then the probability of 1, we didn't calculate it out, but the math was shown in previous slides, is at 0.0508. And the cumulative probability would be of 1 or less would be the probability of 0 plus 1, which is we take our 0.0039, oh, that number's off, 0.469 is equal to 0.0508. So these are the cumulative probabilities of them. And so you just add up what we just did. You find out the probabilities for each number of successes, and you can add them up to get the cumulative probabilities. So as you can see at the very end, remember our rules when it comes to probabilities, that the sum of all probabilities has to equal to 1. Out of our 4 possible successes, the cumulative probability of seeing 4 successes is 1. The cumulative probability always has to equal 1. So 6.5 talks about expected value and variance for binomials. So the expected value is the mean. Remember, expected value mean, mu of a binomial PLF is its balancing point, mean, balancing point, average, and the variance, sigma squared, is its spread. So here are the formulas you'll need to know. So anytime you want to figure out the mean for a binomial, you take your n and you multiply it times p, and that will give you your mu. For our variance, sigma squared is equal to n times p times q. All these symbols are the same ones that we talked about earlier, n being the number of trials, p being the probability, q being 1 minus the probability. Expected value and variance of binomials illustration. So for the 4 patients that we had, where we had x distributed as a binomial for number 4 and 0.75 probability. So to figure out our mu, take n times p, which is 4 times 0.75, which equals 3. So our mu, our average or expected value, is 3. Right? Kind of makes sense. If you had 4 patients at 75% success, you probably would expect 3 of them, on average, to be successful. The variance is our sigma squared, so you take your n times p times q, so 4 times 0.75, and then our q, member, is 1 minus p, which is 0.25. Multiply those out, and you get our variance of 0.75. This is just an illustrated example showing you number of successes on average for your mu3. So using the binomial, so suppose we observe 2 successes in the 4 patient example. We note that mu equals 3, right? Suggests we should see 3 successes on average. Thus the observation of 2 successes casts doubt on p equaling 0.75, and we would say no, because p less than 2 is equal to 0.2617 is not too unusual, right? If we're expecting 3, but we get 2. Is it out of the realm? For this particular example, we would state no. So for my face-to-face class, here's a practice problem that we're going to be doing right away as soon as we get into class that you can work on, and then we'll jump in to our normal routine. So the practice problem is, suppose 7.5% of the population has an infection. I want you to select 5 individuals at random from the population and then calculate the binomial probabilities for these 5 people. So just like we were doing, you're going to want to figure out from binomial distributions for 0, 1, 2, 3, 4, 5 people having it all the way across. Here's your n, here's your p, and you know that your formula for figuring this out is going to be your n cx times p of x, p to the x power, excuse me, and then q to the n minus x power. And you're going to use this formula for each one of these potential successes, or people who are potentially infected. Okay, we're going to go over that, and that will conclude this video. Hope everyone has a great day.